Hi everyone, today's objectives is just to introduce to polynomials. If we start looking at to the left hand side, very first thing is color-coded x to the third power. That's going to be a cube term. That's because it's x to the third power. And your leading coefficient in this case is 3. That's the very first term. And you have a quadratic term. Quadratic terms means you have an x squared. And then the linear term is you just have the x. And the constant term is just a number. So we're going to break all this down when we discuss what is a different type of equation, which is you already know what is a linear equation, what is a quadratic equation, and what's a constant. Constant right now is just a number. You have seen how mathematics use algebraic expression to represent real-world situation. Some of the expressions are monomial or polynomials. And then so in this case, let me give you the definition of monomials. Monomials is an expression that is a constant, a variable, or a product of a constant and a variable that are rise to a whole number power. There's no fraction powers. You guys probably discussed it before, and then so forth. Example 1a, 7, that's a constant. 3x squared, that is a number, a constant and a variable, and another variable, and a constant and a variable, and you can even have a negative, like 0.6 times variables, and you can have variables to the different powers. All those are a monomial. Monomial really come down to it's just one term. And something that's non-monomial is, look at the x squared is in the denominator. That's not a monomial. Monomial is like a monorail, 1. And since this is 1 term, 2 term, 3 terms, that is not a monomial. So that's all we're talking about. Then the next couple things, coefficient of a monomial is the numerical factor in monomial is that number in front of it. A degree of a monomial, the sum of exponent of all the variable in the monomial. So we're going to practice a few of them. Coefficient for 5t to the second power, the coefficient is just the number. It says numerical, so that's just -5. And the degree is just the exponent of the variable. So in this case, it's 2. I'm going to do the next one for you just because it's a little bit trickier. And in this case, it's -mn to the fourth. That's really -1 is your coefficient. And your degree is all the exponents together. I would like you to think about this is also 1 here. So that's 1 plus 4. That's going to degree of 5 is for letter B. And letter C is going to be coefficient. That's just going to be 7. And degree is really x to the 0 power. That's just 1. Why degree has to be 0 to make this all work. And going on. A binomial is a polynomial containing 2 terms. What I just showed you on example 3, A, B, and C, those are all 1 terms. All the things in example 1, those are 1 terms. A term is separated by a plus or minus sign, okay? So I just want to show you a few examples. For example, if you have x plus 2, that's binomial. And then I'd like to show everybody the number is follow the sign. That's why I always insist you guys follow the sign. Tell me what is the sign. And the plus x, even though it didn't write in the front, you guys know that's a plus x. So if I ask you what kind of x is this, you should say it's positive 1. So that's 2 terms. Another example you can have is you can have exponents, x plus y, different kind of exponent, and different kind of variables. All those are totally okay. You can have more than 1 variables in 1 term. You have 5. We can even do negative x to the 5th and y to the 4th. Plus, you can have a half. That's totally okay. Just so you know, there's 2 terms. But you cannot have things that's not a monomial. So you cannot have 1 over 2x plus 2. That is not a binomial because you have 2x in the denominator, so that is not allowed. Going on to the next one, trinomial. A polynomial contains 3 terms. And trinomial is kind of important because a lot of times they might be in the form of a quadratic. Give you some example, that will be something like 3x squared plus x plus 1. And you can even have a negative 2x to the 5th plus 5x to the 3rd minus 1. You can have that. You can even have a half in the front, so you can have negative 1/3 x. As long as the x is in the numerator, it's totally okay. 6 plus 7 over 2x minus 1/2. Those are all three terms. So that is going to be a polynomial containing three terms. And again, if you want to separate them, those are your three terms. And the very first term will be the negative 2x to the fifth power. That's all. All right, going on to the next vocab. Okay, so now I want you guys to try this. Indicate whether the expression is a monomial, which is one term, binomial, which is two terms, and then trinomial is three terms, or no special polynomial name, which is in this case anything more than three, or it's not a polynomial. So I'm going to pause my video and you guys go ahead, answer the question, and check back with your answer. Example 4 is monomial, one term. Example 5 is trinomial, three terms, one term, two term, and three term. And then the next one, example 6 is two terms, and example 7 is not a polynomial is because the y is in the denominator. So that is the example 4 through example 7 answers. Next one, going on, a constant is a term that has no variables. For example, it's going to be like a half. You can have a negative 2. You can have negative 7.5. All those things are acceptable. Make sure you understand a constant just doesn't have any kind of variables. And then so the next thing, polynomial is a monomial or sum of difference of monomial. Sum or difference of monomial. The reason for that is because you are just collecting more than one terms, and that's a polynomial. One term we have special name, two terms we have special name, three terms will have special name, and eventually as time goes on, if you learn more math in college, you will learn the different terminology for more key features of a polynomial. Really quick sum of everything. Each monomial in a polynomial is called a term. That's one term, two terms, three terms. No variables can have negative exponent or no variable in the denominator with anything that's 2 over x or the negative exponent, so it's going to be x to the negative 2 power. Those are not acceptable, so those are not right. No variables can have fraction exponent when simplified. So you guys have not had time to learn this. X to the negative 1 over 2 power, 1 over 5. No variable as an exponent. You cannot have things like y to the x power. That's all those is not allowed. I'm going to cross them out with a highlighter so you guys understand. Those are not allowed. No. A couple other things I want to just quickly cover because I think most of you guys had this before. Degree of polynomial, the greatest degrees of any, here's the keyword, terms in the polynomial. Now what you're going to do is you are going to figure out the terms. Each term, for example, number 8, that's one term. That's 2, 3, 4, 5. Those are individual terms. And every term, so we talk about what is the highest degrees. We did that before. So you should be able to say first one is 4 degree. The second one is the 9th degree right here. Those are your degrees. And the third one is the 7th degree. And the fourth is the x to the first power, and so it's the first degree. And 19, since it's not negative 19, it doesn't have x to the 0 power, 0 degree. So identify degree of each polynomial. That's whole polynomial. When they say degree of each term is 4, 9, 7, 1, and 0. The leading term is going to be 15x to the 9 because that's the highest one. The degree of going to be the polynomial is the highest number. So in this case, it's 9 because that's the biggest number right here. Okay, that's the highest number in your exponent. So your degree is the highest exponent. Coefficient of each term, if you're just looking at each term, that's just the number if on the variable. So the first one is going to be 1. The second one is positive 15. The third one is negative 3. The fourth one is negative 7. Then the last one is negative 19. So x to the 0 power. That's all. Okay, the leading term is the highest exponent. I want to pause and then you guys try number 9 and then we can check your answer. I want you guys to take a look at the example right here. This one has 2 letters. That one has 2 letters. Now when you have 2 letters, you combine the little guys which is your exponent inside. So you are combining 5 and 4. That's why that gives you the 9 right here. And this is 1 right here. So 1 plus 6 give you 7. That's 7 right here. So I hope you guys understand that. And that is right here. And then, so because of that, the leading term is going to be to the ninth power. It's going to be -9. And the degrees of polynomial, which is going to be 9 degree, and those are coefficient of each terms. Going on to the next one, number 10. Number 10, I just want you guys to see, can you plug in the number and double check? Can you cube it with your calculator? Can you square it with your calculator? And can you still follow the order of operation rules? Pause your video, work it out, and check back with your answer. I'm going to just show you the answer, which is -5, and you make sure that you show your work and see how you get the -5. Let's take a look at example number 11. It says here, combine like terms. I hope you guys remember what that is, but you don't, I will review it. And write the resulting polynomial in a descending order or degree. So that means the highest exponent degrees first, and write it in the polynomial in a standard form. That's the highest degree of polynomial, and going down in the exponents. So make sure you understand that. So in this case, what you have here is I'm going to combine like terms first, and I'm going to try to make sure that all the degree of each term and leading terms and degree of polynomial and coefficient of each term, I will answer that. So to add them, just to make sure that we can split them up like this. And the reason I do that is because that way I don't forget my terms, and as the problem gets harder, I want to make sure I collect everybody. So the very first thing I'm going to look at is x to the third power. And x to the third power is -2 plus 1, and that's going to be -x to the third power. And then the next one I'm going to look at is the second power. If you do that, you pretty much take care of everything. And I notice that I also underline. So second power is this guy and this guy. And then so it's 12 plus 5, that's going to be plus 17x squared. Notice I also notice my sign, so I say it right away. So I mark it, those two terms are done. Then the next one is going to be the x term. The x term, I'm going to do the squiggly line. Now I have two of them. So that's going to be 6, positive 6x minus 5, that give me plus x. And the last one is going to be -13 and positive 2, so that's going to be -11. And that is all I have to do, putting in the standard form. Standard form means from the highest exponent to the lowest exponent. And so in this case, we are going to take a look. Degree of each term. The first term is 3. The second term is 2. The next one is 1. And the last one is 0. Leading term is going to be -x to the third power. And degree of a polynomial is the third degree because that's the highest, the largest for all the terms together. EST. Okay, all the terms together, which one it has the highest? So it's 3. Coefficient of each term in this case is going to be -1, 17, and 1, and -11. I show you how to do 11. Please try 12 and 13 yourself, and then we'll come back and check on the answers. So for example number 12, I combine like term, -2y to the third plus 5y to the second minus 5y. Degree of each term is 3, 2, 1. Leading term is the very first one, -2y to the third. Degree of polynomial is the highest, which is 3. And coefficient of each term is -2, 5, and -5. Okay, number 13 is a little bit tricky. I don't think you guys will have anything like this right now, but I do want you to be able to answer degree of each term. Again, this is first one is 2. The second one is going to be those two together, and there's 1, so that's why it's 3 right here. Okay, and same thing right here. That's also gives you the 3. But anything else, leading terms, that's a little bit hard for you guys to decide. Depends on the situation. So we're going to not talk about it. And same thing with a degree of the polynomial because they both have a 3. technically it's 3, but we are not going to talk about that. Coefficient of each term, which is going to be just the number in front of each term. So please double check. 14, just a quick review. We are going to distribute the mononomial to a polynomial. So in this case, you pretty much just have to do a distribution this way. Make sure everybody multiply. And you guys know how to do that because we just solved the equation, solved the system. You know you have to multiply every single term in the polynomial in your equation. So that's the same thing as distribution. And I would like you guys to try it, and I will pause the video and do 14, 15, 16. We come back and give a real quick binomial times binomial. Here are the answers for number 14. And make sure you double check your exponents. 15 exponents, make sure you understand you add the exponent 4y squared times 2y squared is ay to the fourth because you are multiplying, you are adding your exponent all the way through 16. 16 you just have to distribute backwards, so it's not that big of a deal. So a to the second become a to the fourth, b to the fifth, b 5 plus 1 more, that's 6. Then you have negative a to the fifth because that's a 3 and the 2 right here. So you have 3 and the 2. So when you add them together, that gives you 5. And you have a b and the b, that's a b to the second because it's b to the first and b to the first. And then so those are 14 through 16. Then we talk about FOIL, which is I don't like to say FOIL. I like to say first term times everybody into the second parenthesis, second terms times everybody in the second parenthesis. That's all. So go ahead, do your FOIL or do your distribute every single term. The reason for that is because I would like to show you 20. I would like to show you a problem x plus 5 times 2x to the second minus 3x minus 1. When you have things like this, you need to make sure to how to distribute. And in this case, it's just the first term times everybody else in the second term. And you take the very second term times everybody else in the next one. So for this one, I'm going to work it out for you. And that's just going to be x times 2x squared. That's going to be x to the third power. X times negative 3x, that's going to be negative 3x squared. And you have x times a negative 1 is negative x. Then you do the pink highlighter. 10, positive 10, because positive 5 times a positive 2 is positive 10x squared. And then positive 5 times negative 3 is negative 15x. And the last one is positive 5 times negative 1. It's going to be negative 5. And then you got to combine like term. Make sure you write it in a standard form, which is the highest exponent to the lowest. So I'm going to start with x to the third, and I'm going to separate them so you guys can see which term so this one's already collected. Then I have 2x squared term. One of them is negative 3, one of them is positive 10. That's going to be plus 7x to the second power. Remember, this is an addition of the number, so you don't do anything with the exponent. Then the last one, which is 3 lines and 1 term, that's going to be negative x and negative 15. Remember, I'm saying the sign, which is negative 16x. And the last one, which is minus 5. Again, the highest exponent, the degree of this polynomial is 3. The leading coefficient is x to the third. The constant for the leading coefficient is going to be 1. And this is a polynomial. Any question on that? Okay, so that kind of question, I do expect you guys to be able to handle that now. That's one thing. Second thing is I also want you guys to, for number 19, make sure you write it out as x minus 2 times x minus 2. And that is a must because you guys are going to skip it and you're going to forget to distribute everybody. Okay, it's not the exponent, it's writing the parenthesis out. So go ahead, do your for 17, 18, 19, and then come back and check your answer. Here's the answer for example 17, 18, and 19. You understand you have to distribute them so you can get all the terms, and that is going to be, I do it just the same way I do it with the 3 terms. The same method for 17, 18, 19 can be done the same method as number 20. That concludes the notes for introductory to polynomial, and thank you so much for watching.